Hello again, class. Welcome to lecture 2 of week 9. And again, we're still on the topic of spectrophotometry. Okay, so last time we discussed about Beer's law, but first we introduced about spectrophotometry. What's the difference between the terms spectrophotometry and spectroscopy? We defined and investigated the nature of light and the nature of radiation. And we somehow applied these principles in the absorption process, wherein you have your Beer's law, which is a limiting law, okay, that shows the relationship between your absorbance and the concentration of a sample. Okay, and usually we can do that using the regions of your electromagnetic spectrum, which are UV and visible radiation, kasi sila yung nag-enable ng electronic transition or absorption doon sa inyong mga samples. For the rest of the regions of the electromagnetic spectrum, tulad ng X-ray, IR, gamma rays, NMR, microwave radio, iba naman, kanya-kanya naman yung ginagawa nila sa iyong molecules or atoms. So yung iba doon nagko-cause ng change in nuclear configuration, yung iba doon change in nuclear spin, but we focus on the change in electron configuration, wherein nagkakaroon ng electronic transition, yung electron mo from one energy level to the other energy level. So that's your absorption process basically. Here I'm showing yung plot ng absorbance versus wavelength. Remember, if you are going to do a measurement, okay, let's say you want to determine the absorbance of a series of samples with, of course, using the same kind of sample, okay, pero you have, let's say, an aliquot of that. So, ang ginagawa is you will scan first using the spectrophotometer kung ano yung gagamitin nating wavelength of absorption. Because, of course, naturally, we would go for the wavelength. We will use the wavelength in the light kung saan maximum yung absorption. Okay, so we call that the absorption spectrum. So it's the plot of absorbance versus your wavelength. And this example here is the absorption spectra of potassium permanganate. And you can see here 5 curves because it's done with different concentrations. Since isang sample lang yan, you can see that the wavelength of absorption na maximum or the plot or the peak of the spectrum ay isa lang for all concentrations, and that's around at 5 to 5 nanometers. Okay? So here, if you're going to check, if you're going to plot the concentration versus the absorbance, you will obtain a linear relationship because this obeys your Beer's law. Okay. Now, again, the point there is that the relationship between absorbance and concentration is linear. So here, if you're going to plot absorbance versus concentration, whatever that concentration is, percent, ppm, or molar concentrations, but usually your molar absorptivity epsilon is written with units of liter per mole centimeter. Okay? So that's why your concentration na kailangan gamitin ay molar concentration. But again, you can use ppm or other units of concentration. So the slope of this relationship will be, of course, epsilon times dB path length. And if you have this as constant, so you'll have a constant slope. Okay? Now, may mga pagkakataon na hindi nagiging linear yung relationship nila. And that's because of some limitations to Beer's law. And we can classify these limitations based on whether it's a real limitation or because of the instrument. Okay? Or it could also be because of some chemical changes or deviations in your sample. So let's start with the real limitations. Si Beer's law kasi, isa siyang limiting law. Sa chemistry and physics, pag sinabi nating limiting law, it holds true only under some conditions. An example of a limiting law aside from Beer's law is yung tinatawag nating Debye-Huckel limiting law. Okay? Beer's law, on the other hand, kaya siya limiting law kasi totoo lang siya kapag dilute yung conditions. Because at concentrations exceeding 0.01 molar already, ang nangyayari kasi masyadong concentrated na yung sample, the average distances between ions and molecules of the absorbing species are diminished, no? To the point where each particle affects the charge distribution, okay? And thus the extent of absorption of its neighbors. Okay? So tabi-tabi yung mga molecules, therefore hindi nagiging efficient yung absorption, okay, ng bawat molecule. So what happens here is that your Beer's law relationship becomes a little bit nonlinear. So up to a certain concentration, ito, which is usually ang 0.01 molar, okay, linear pa si plot. But after that, if you have high concentrations, nagkakaroon ng pagbaba ng curve. Okay. Another type of change or deviation is chemical in nature. So kapag yung absorbing species mo dun sa sample ay nag-undergo ng association, dissociate, or reaction, in other words, nag-i-interact yung mga species sa mixture or sa sample mo, then that might result to your Beer's plot na hindi linear. Ibig sabihin, nagkakaroon ng deviation or limitation. Okay? Kasi nga, syempre, kapag, let's say for example, yung species sa loob ng sample mo ay nagkaroon ng reaction, they react with each other, they interact with each other, they might give complexes or products that have a different absorbance than that from the analyte. Okay? So for example here, what you're seeing is a plot of absorbance versus concentration ng isang indicator. So indicator usually it's ionic in nature, no? So kapag mas malaki yung fraction nung, let's say, nung cation, okay, iba yung nangyayari. Kapag mas maliit siya, iba naman yung nangyayari. So if the curve is something like this, it concaves downward or it curves downward. So it means positive yung deviation. Kapag it curves upwards, no, negative deviation siya. Okay, there are also limitations that are instrumental in nature. And one of them is kapag ang ginamit mo doon sa equipment ay polychromatic radiation. Ano ibig sabihin nun? Yung light kasi or radiation, pwede siya magkaroon ng iba-ibang form. May monochromatic, may polarized, may coherent, okay? But we will not discuss all of this. Pag sinabing monochromatic kasi, iisa lang yung wavelength na ginagamit mo dun sa spectrophotometer. Okay? And that's ideal. Dapat sa spectrophotometric measurements, isang wavelength lang ang gagamitin. Okay? So we call that monochromatic. Polychromatic kapag iba-iba yung wavelength ng rays of light. Okay? As you can see in here. In lasers are actually monochromatic. At the same time, they are coherent in that they have the same amplitude, they have the same frequency, they have the same wavelength as well. Anyway, so the point here is that in these kinds of measurements, you go with a monochromatic source of radiation. Okay? Older instruments, hindi masyadong monochromatic ng radiation nila. Newer instruments, so they have this kind of radiation. But what we do if you have a polychromatic source of radiation is that you install diffraction gratings or other instruments, optical instruments that will somehow change your polychromatic radiation into monochromatic radiation. Ibig sabihin, pinifilter mo yung light in the process. So if you're going to see here, it's usually a negative deviation kapag nagkaroon ka ng polychromatic radiation. So if you take a look at the first or upper curve, parehas lang sila ng wavelength, parehas lang sila ng absorptivity. For the others, magkakaiba na kasi sila ng absorptivity. And that's the reason, that's the cause or effect rather of using polychromatic radiation. Another instrumental limitation is the presence of stray light. So ibig sabihin ng stray radiation is radiation na nanggagaling kung saan. It's from the instrument, yes, but it's outside the nominal wavelength chosen for the determination. Remember, you're going to scan, you're going to determine the maximum wavelength of absorption. Kaso nga lang, nagkakaroon ng stray light which is coming from scattering and reflection of the surfaces of some parts of the equipment like gratings, lenses, mirrors, and even filters. Okay, so here you can see the effect of stray light. Okay, so the first curve, upper curve, is no stray light, 0%. But if there is presence of stray light, it will result to negative deviations. And to calculate the apparent absorbance, di ba meron kang absorbance ng sample mo? Pero kapag may stray light kasi, ang makikita mong absorbance or ma-measure mong absorbance ay apparent absorbance, hindi yung actual absorbance ng sample. And what you do is take the log of this, no? As what you're seeing in the formula. Okay, another, well, trivial but important limitation is, of course, if you use mismatched cells, halimbawa yung blank solution mo sa determination, okay, kasi usually, mag-uumpisa ka sa blank. Okay? And then, yung measurement mo sa analytes or samples mo with reference to the blank solution. So the blank solution here means yung solution mo without containing the analyte. Halimbawa, water lang yan. So it could be a blank solution. It could be any solvent or it could be anything basta hindi nilalaman yung iyong analyte. So, ang nangyayari kasi minsan, nagkakamali, nagkakaroon ng mismatch ng cells. So, meaning they are not of equal path length, okay? Or even if they have, but if they differ in optical characteristics, medyo for example, mas madumi yung isang cell o kaya mas mataas or mas mababa ng konti yung index of refraction niya. So that could be also a limitation. But you can correct that kasi ang mangyayari naman dyan is if you are going to plot Beer's plot, then you will see it as a y-intercept. Okay. Now let's go to your application or analysis. Paano natin gagamitin yung Beer's law principle, yung spectrophotometry in the determination of unknown samples? So I will discuss two methods for this application. The first one being the calibration curve method, and the second is yung tinatawag nating standard addition method. Okay, so let's start with this calibration curve method. So ang ginagawa kay calibration curve method is that mayroon kang known concentrations of a given solution, and we call them standards. Okay, and measure the signal. Okay, so ito yung mga known concentration. So nag-prepare ka ng standard, 5 ppm, 10 ppm, 15, 20, 25, 30. This is just for example. So you know the concentration of that standard. Okay, so what you will do is you measure the signal of each standard. And when I say signal, ibig sabihin any measurable value. If you're doing a potentiometric measurement or electrochemical measurement, pwede siyang maging, yung signal mo ay pwedeng potential, pwedeng voltage, pwedeng current, pwedeng resistance, pwedeng conductance, conductivity, okay? Pwedeng pH. So anything that can be shown as a signal or measurable value, signal yon. But in this discussion ng ginagawa natin ngayon, yung signal na gagamitin natin, kasi spectrophotometric measurement tayo, absorbance. Okay, pwede ring emitted signal or intensity. Okay, but in these examples, we will be using absorbance as our signal. So what you're going to do is you plot the signal, kasi diba, meron kang 5 ppm standard, kinuha mo yung absorbance, and then next 10 ppm, kinuha mo yung absorbance, 15, 20, 25, 30, etc. So ito yung mga nakuha mong absorbance, for example. What will you do is you plot those concentration values versus the signal. And usually you will obtain a straight line. Okay? So, next na gagawin mo, meron kang unknown. Okay? Yung unknown, syempre hindi mo alam yung concentration, may measure mo ngayon yung kanyang signal or absorbance. So, halimbawa, yung absorbance ng unknown mo ay 125, which is somewhere here. So, what you will do is determine the concentration based on the plot. And you find out here that the concentration is somewhere between 10 and 15, so around 12. Ibig sabihin, we have successfully determined the concentration of the unknown sample. So that's one way to determine the concentration of unknowns. Okay? Of course, we don't usually do this graphically. with a piece of paper or graphing paper. We do this in Excel, and you don't really have to read off the concentration ng unknown. Kasi what you can do is, if you plot the Excel graph, you can establish the relationship by determining the equation of the line, di ba? Madalas natin yung ginagawa, yung y equals mx plus b. So alamin mo yung slope, alamin mo yung y-intercept. Sa graph na nakita mo dito ngayon, wala siyang y-intercept. So y equals mx lang. So you determine the slope, determine the y-intercept, and from that, you will be able to write the equation. Or usually, actually, nung sa Excel plot, bibigyan niya na sa'yo yung equation of the line. So from the equation of the line, y equals mx plus b, since alam mo si m, alam mo si b, alam mo si y kasi yun yung signal, makukompute mo si x, which is the corresponding concentration. Okay? So let's have this problem. And I will give you time to kind of read the problem once, twice, 3 times maybe. Make sense out of this problem, intindihin yung mabuti. So you can go ahead and pause for a while and basahin nyo lang, okay? Para we can answer it right away. So, kung nabasa nyo na yung problem, na-pause nyo na and nabasa nyo na yung problem, let's try to read again and find the solution. So, ang ginagawa dito is that, okay, let me kind of read this. So, one common way to determine phosphorus in urine is to treat the sample after removing the protein with molybdenum and then reducing the resulting 12-molybdophosphate complex with ascorbic acid to give an intense blue-colored species called molybdenum blue. Okay, so medyo mahabang statement yon, but ang ibig sabihin lang niyan is you have a sample, okay, you react to it with a certain compound, okay, para makapag-absorb siya. Alright? So, yung urine, tatanggalan mo daw muna ng protein and then react with molybdenum 6 to form a complex. Yung complex na yun, siya yung mag-absorb ng UV or visible radiation. Next, the absorbance of molybdenum blue can be measured at 650 nanometers. Okay? So, ibig sabihin siguro, yung 650 nanometers, siya yung wavelength of maximum absorption. Either na-scan na natin para malaman yung wavelength na yan, or there is some way kasi, usually dinidiscuss organic chemistry, kung paano somehow i-estimate or i-calculate yung wavelength of absorption based on the structure. But pwede yun. I think, if I'm not mistaken, we call that Woodward rules or Woodward-Fisher rules. Okay? If I recall it correctly. Anyway, meron kang urine sample, 24-hour. So, probably, we don't know the actual procedure, but maybe ang requirement for this analysis is that yung urine sample mo dapat fresh. So, ang fresh siguro sa kanila ay 24-hour. I don't know why it's 24 hours. Maybe the intention of this study is to calculate the concentration of phosphate doon in a 24-hour time interval. Now, kasi ganito, no? Yung patient, during the 24-hour time, nakapag-produce daw siya na 1,122 ml in 24 hours. You can verify it if you want. Kung gusto mong malaman kung ilang ml ang napoproduce mong urine sa isang araw. So, sabi dito na sa problem, I'm not sure if this is accurate, nasa 1.122 liter daw. Now, from that 1,122 ml, kumuha ka ngayon ng 1 ml alico. Okay? Or 1 ml representative. And you treat it with the molybdenum complex nga na kanina para maging absorbent siya or absorbent siya ng UV-vis radiation. Okay? So 1 ml representative sample from the 1.122 liters. After you perform the complexation, idadilute mo siya ngayon to a final volume of 50 ml. Next is you will prepare a calibration curve by treating 1 ml alico of phosphate standard solutions. So, ang ibig sabihin nun, mayroon kang standard solutions ni phosphate. Okay, available. Either available siya or piniprepare mo siya ng fresh. May 1 ppm ka, 2 ppm, 3 ppm, 4 ppm. Known to mga to kasi na piniprepare mo to, it's apart from the sample. Okay? And 1 ml each yung kinuha mo. Okay? Now, the absorbances of the standards and the urine sample were obtained at 650 nanometers. So ito yung resulta. Yung known concentration mo or known standard mo na 1 ppm, 0.230 yung absorbance. Pag 2 ppm, 0.436, etc. hanggang 4 ppm. Ang next mong ginawa, kinuha mo na yung urine sample mo. And remember, yung urine sample mo, 50 ml siya. Diluted kasi, 50 ml. And you found out that the absorbance is 0.518. So if you are not doing the calculations or the plotting yet, 0.518 is somewhere between 0.436 and 0.638. So maybe yung concentration niya is somewhere around between 2 and 3. So you can figure that out later. So ang gagawin natin, let's calculate the phosphate concentration dun sa urine ng tao. Okay? So what you will do is take your Excel and plot yung 1, 2, 3, 4 versus the measured absorbance. Okay? So if you want, while you are viewing this video, you can open your Excel and try to plot it and see if you will get the same curve, meaning that linear. Okay? So yung 1, 2, 3, 4, yung ppm concentration, x-axis yan. And yung signal, which is in this case absorbance, y-axis. So the best practice lagi is that yung signal, whatever that signal is, absorbance, emitted radiation, intensity, potential, pH, lagi siyang y-axis. Yung concentration mo laging x-axis. Okay. So pinlat mo na ngayon, you can see it's a straight line, fairly straight line. But what is the equation of that line? Dito sa screenshot ko, I obtained the slope and the intercept. Okay, so let me highlight that. So meron kang slope, meron kang intercept. Pero in your Excel kasi, automatic naman yan na ibibigay niya yung equation of the line. Okay? So therefore, ang equation ng line is absorbance equals 0.2056 kasi yun yung slope plus yung y-intercept which is 0.024. So again, sa Excel, automatic ibibigay niya ito. Basta i-click nyo lang yung yung function na you will add the regression line after plotting. So this is a scatter plot actually. Now, since you have this equation, ngayon, ang sunod na ginawa, di ba meron kang unknown urine sample, you measure the absorbance. So yung 0.518 na yan, isa-substitute mo ngayon dito sa absorbance para makuha mo yung unknown concentration. So let's do that. If you're going to solve C in terms of A, ito yung itsura ng equation, right? Simplify nyo lang. So, substitute yung A ng 0.518 kasi yun yung unknown absorbance. And just carry out the calculation, you will determine that C will be equal to, or the concentration will be equal to 2.4 milligrams per liter or 2.4 ppm. So as we can see, tama tayo na it's somewhere between 2 and 3. But that's not yet the final answer. Okay? Kasi remember, you diluted your sample. So ito kasi yung concentration pa lang nung dilute sample. So how do we calculate this further? Unang-una, gusto natin munang malaman, based on the problem, ito isa sa mga requirement, questions, gaano kadaming, what's this? Phosphorus. So let's check nga. The question is, yes, letter B, what mass in grams of phosphorus was eliminated? So, okay. So to get the mass of phosphorus eliminated by the person, okay, so ilan ba yung ihi niya? 1122 ml. Pero alam na natin ngayon na ang concentration dun sa ihi for the dilute sample is that for every liter, which is 1,000 ml yung 1 liter, mayroong 2.4027 milligram. Okay, so pag kinancel mo yan, okay, malalaman mo na yung milligram. Okay, so ml, ml. Ganyan karaming milligram. Pero remember that this concentration is the concentration of the dilute solution. Kasi kanina, di ba, dinilute natin siya. So ano yung dilution factor? It's 50 to 1. Okay, so you have to multiply by the dilution factor 50 ml to 1 ml. Kasi, di ba, 1 ml yung aliko, pero dinilute natin into 50 ml. So finally, we get that the mass of phosphorus eliminated by the person sa isang araw ay 135 milligrams. Okay? Now, what if I want to calculate the concentration of phosphate instead of phosphorus? So ito yung concentration mo nung unknown, di ba? But again, we diluted it. So you have to multiply first by the dilution factor. Now, since phosphate ang gusto nating malaman, so what is the relationship muna between phosphorus and phosphate? So 1:1. So ito yun. But gusto natin, let's say, molar concentration. So i-convert muna natin yung milligram to millimole. So 1 millimole of phosphorus is 30.973 milligram. So it will give you the concentration of phosphate will now be 3.87 millimolar. So that is your calibration curve method. Okay. Now, the second method that I'd like to discuss is the standard addition method. Bakit natin siya ginagamit? It's used to eliminate what we call matrix effects. Yung matrix kasi, class, is yung kung nasaan yung analyte. So let's say you have the solution. Okay? All other components, aside from the analyte, yun yung buong matrix. And may effect si matrix dun sa ating determination kasi, di ba kapag calibration method or yung standard curve method kanina, ang nangyayari is that may iba-iba kang aliko. May iba-iba kang standard solution. Pero kasi may effect yung matrix dun sa analyte. So pwedeng maapektuhan yung signal. Hiwa-hiwalay kasi yun eh. So pwedeng yung first standard solution mo freshly prepared pero yung second kahapon pa. So pwedeng magkaibang effect. Okay, let's say na para lahat sila freshly prepared. Still, you cannot somehow avoid deviations like chemical deviations, even instrumental ones. So we would like to eliminate those kinds of effects. So we will use your standard addition method. So in the standard addition method, ang pinagkaiba dun sa calibration curve method, di ba kanina, meron kang standards, meron kang signal. Yung standards, known yun. No? Ngayon naman, ganito ang gagawin. You start with the unknown and measure the signal. Now, that unknown solution, you will add known amount, which is in here in this example, 5 ppm, measure the signal, and then add another 5 ppm, measure the signal, and then add ka lang ng add. Okay, so lahat ng row na to, puro may unknown. Okay? Iba-iba nga lang nung in-add na analyte na known. So yung ina-add mong analyte, ang tawag dun spike. Okay? So what you do is to take the plot and for you to be able to get the concentration, it's extrapolate direct here. So yung linear plot na yan, kung ano yung nagko-cross ng x-axis, siya na yung concentration. So ganoon lang kasimple yan. Pero medyo matrabaho siya, di ba? Although halos parehas lang nung calibration curve method, you just have to add and add and add. But sometimes, para mas mabilis yung ginagawa, they do what we call single point standard addition. So, ibig sabihin nun, balik tayo dito, ito yung unknown mo, you measure the absorbance, for example. Nag-add ka ng spike, which is 5 ppm na standard, which is known, in-add mo dun sa unknown, you measure the signal, and you stop there. So sometimes, ganito yung ginagawa nila. Single addition lang yung nangyari. We call that single point standard addition. And if you do that single point standard addition, medyo mapapabilis yung ating calculation. But if you do multiple points, you do it graphically, right? Mas accurate yung multiple points, of course. Pero for speedier determinations, you can go ahead and use single point standard addition. So, ang nangyayari dito is that meron ka ng signal or let's say absorbance ng sample, di ba kanina? And you also measure the signal or absorbance ng spike solution. Ibig sabihin, di ba nag-add ka ng spike? Ano yung absorbance nun? Okay? So, kasi yung absorbance or signal, proportional siya sa concentration. Tama ba? So, this is always true. The signal is proportional to the concentration. Okay? So, if you divide or take the ratio of the signals ng sample tsaka ng spike, again, spike, ibig sabihin yung dinagdag mo dun sa anong. Okay? E di, i-take the ratio rin ng concentrations ng sample tsaka ng spike. So, this is the concentration of the sample. This is the concentration of the spike. And that's equal to the ratio of the signals of the sample and the spike. So, S sample corresponds to the concentration of the sample. So, yan yung unknown concentration. And usually, yun yung hinahanap natin. Concentration ng unknown sample. But, how do you get the diba ito yung signal ng spike, ito yung concentration ng spike. But how do you get that? How do you get the concentration of the spike? So, please understand this, no? You can, yes, memorize the formula, pero paano pag nakalimutan mo yung formula? Kasi medyo, hindi naman sa komplikado, but probably, it's quite a long one for you. Ang gawin mo is, intindihan mo yung ibig sabihin ng formula. So, to get the concentration of the spike, ganito siya. Di ba ito yung sample mo? Concentration. Pag minultiply mo siya ng volume ng sample, anong lalabas? Siya yung amount ng original sample. Let's say ang sample mo milligram per ml, concentration, times the volume which is ml, milligram na lang matitira. So that's for your sample. Pero nag-add ka, di ba? In-spikean mo siya. Right? You added a spike. So how do you add that? What is the concentration of the spike? Kunin mo yan. It's known, di ba? Alam mo kung ano yung in-add mo. Concentration ng spike. Tapos alam mo rin kung ilang volume in-add mo. So malalaman mo yung milligram or mole, whatever, or amount ng spike. So this term here corresponds to the amount that you added na spike. That plus the original amount ng sample is the total amount. Divide mo sa total volume, then yung concentration ng spike. Yung total volume therefore is just equal to volume ng sample plus volume ng spike. Okay? So, ganun lang. And let's revisit the determination again. Kanina, it's urine determination or phosphate in urine determination. So, let's do another version of that problem, but this time, iba na yung mga given. Okay? So, let's answer this. You can pause this first. Read the problem 1, 2, 3 times. Intindihin nyo muna. And if you have done that, then let's proceed. You perform here a single point standard addition. Okay? So, you started with 2 ml urine sample. Treat it with molybdenum blue reagent. Ito yung kanina, di ba? To produce a complex. Absorbing at 820 nanometer. Probably magkaiba ng konti kasi kanina 600 something ata yung nanometers. Ito 820. Tapos, after doing that, from your 2 ml sample, dinilute mo ng 100 ml. Okay. Tapos, kumuha ka ng 25 ml dun sa 100 ml. And that 25 ml alico gave an absorbance of 0.428. Now, next is you added 1 ml of a solution containing 0.05 mg phosphate to a second 25 ml alico. And it gave you an absorbance of 0.517. So malamang yung absorbance kanina, ito yung absorbance ng unknown. Siya yung absorbance ng sample. Ito naman yung absorbance ng spiked solution. So use this data to calculate the mass of phosphate in milligrams per ml. Okay, let's go. So you started with a 2 ml sample urine. And what's next is you diluted it to ilan? 100 ml. Yung 100 ml na yan, complex na yan. Ibig sabihin, absorbing na siya. But to perform the experiment, hindi yung buong 100 ml ang i-test mo, kundi 25 ml alico lang. When you tested the 25 ml alico, you obtain 0.428 na absorbance. Next, another 25 ml alico, ang ginawa mo doon is nag-spike ka. Spike. Dinagdagan mo siya ng 1 ml with 0.05 mg phosphate. Ibig sabihin, yung concentration na nilagay mo is 0.05 mg per ml. And yung volume na nilagay mo is 1 ml. So, ginawa siya sa isang separate alico. But, you can actually do it in the same alico. Okay? Pwede mong ilagay, spike mo dito yung nilagay mo. You can do that. So, pwedeng magkaibang alico, pwedeng the same alico. So when you did this, you obtain an absorbance of 0.517. So usually, a good practice to solve determination problems in analytical chemistry is you draw the diagram or the sequence of events that happen. Okay, para you can keep track of what's going on. Okay. So let's use the formula, di ba? We are using here single point standard addition. Okay? So ito yung formula kanina pero pinalitan ko na yung S ng A kasi we're using absorbance. A sample over A spike is C sample over C spike. So C spike is kunin mo yung concentration ng sample mo, which we don't know, times the volume ng sample. This one we know. And the volume of the sample here is, yung tines mo is 25, right? Okay, so volume ng sample times C sample is the amount of the analyte. Idagdag mo yung amount ng analyte na nilagay mo or pinang-spike mo. Okay, how to do that? Just multiply the concentration of the spike times the volume of the spike. Okay? And then divided by the total volume. So let's substitute what we know. A sample or absorbance of the sample is 0.428. Absorbance of the spike is 0.517. C sample is what we're looking for. C sample. Volume ng sample, 25 ml. Kung naalala natin, nandito rin siya. Now, for the concentration of the spike, sabi, nag-add ka ng 0.05 mg doon na yun yung laman ng isang ml. So yun yung concentration. Ilan in-add mo? 1 ml, 2 ml, isang ml lang din daw. So divided by the total volume. So ang total volume is 26 ml. Saan nakuha yan? 25 ml plus 1 ml. Or actually ito yung 25 ml plus 1 ml. So isang unknown na lang yan, which is the concentration of the sample. So therefore, that's using your calculators, you can use shift solve 0.0078 milligrams per ml. Ganun lang kasimple. However, hindi pa yun yung final answer because remember, may part dito na dinilute mo yung sample. So what will be the dilution factor? It's 100:2. So the actual or original concentration is whatever you answer kanina times 100:2 dilution factor. And the final answer therefore is you have 0.390 milligram per ml of phosphate. Okay, so those are the two methods for the determination of unknowns using signals. And again, signals could be absorbance, potential pH, but we are focusing right now on absorbance or spectrophotometric signals. Okay, so those methods are standard calibration method, wherein you have a set of knowns or known concentrations, measure each signal, and then take a plot, graph it, take the equation of the line, and from that equation of the line, you'll be able to determine the unknown. Or we can use the standard addition method. And usually, for quick determination, we use the single point standard addition. Just remember this formula. And also, please remember, please be careful na kung ano yung sagot na ma-obtain mo from the formula, hindi yun basta-basta yung sagot. Remember what happened during the process. So if there's a dilution, then you have to multiply by the dilution factor. So in our next lecture, we will talk about more applications of spectrophotometry and ano yung iba-ibang techniques or instruments that we can use for different kinds of determination, but we will somehow focus on biological determination or biological systems.